Greetings everyone. I am Sheikh Saifur Rahman Johnny, currently an undergrad at Bangladesh University of Engineering and Technology. I will be presenting our paper, Linking Tourists Towards Geolocalized Policies COVID-19 Perspective, co-authored by me, Sheikh Saifur Rahman Johnny, and Dr. Rifat Shahriar, Dr. Mohammad Saifur Rahman, Dr. Mohammad Sohail Rahman, and Dr. Tanvir Alam. This is a collaborative project between Bangladesh University of Engineering and Technology and Hamad bin Khalifa University, Qatar. Our paper is subdivided into different sections: background, dataset collection, methods, result and discussion, verification on independent dataset, and conclusion. So let's start. We'll start with the introduction to Twitter. Twitter is one of the most popular social media platform out there with 330 million active users at the first quarter of 2019, and many people share their activity information and express their mood through Twitter. As a result, Twitter has experienced heightened usage by its users during the pandemic period. So, many researchers have been actively analyzing Twitter for developing tools to analyze public emotion. For example, Zane and others developed a method to identify the most influential Twitter user in COVID-19. And similar angle have been taken by Haman with the twist that he analyzed the tweets done by the state leader along with public's reaction thereto. Now, dataset collection. For our analysis purpose, we use the Twitter dataset curated by Ravindra Lamsal, which contain tweets related to COVID-19 and sentiment scores calculated by them. As per Twitter policy, only tweet IDs can be shared. Hence, this dataset contains only tweet IDs related to COVID-19. We use Twitter API to collect the whole tweet object. We collected tweets from March 19, 2020 to April 17, 2020, which summed to 24.5 billion tweets and required 100 GB of space. We were able to extract country-related information for 9.51 million tweets. Twitter provides a user location field, which is optional for the user to provide. And we use this field to collect states and country-related information. We use some Python libraries to extract this information and to ensure meaningful analysis, which chose countries that had at least 500 tweets per day during the whole analysis period. Using this threshold, only 20 countries were filtered. We also work on the subset of US tweets dataset. We could extract state-related information for 2.74 million tweets that was generated from USA, and using the same threshold provided above, we could analyze 28 states. Here are the frequency plot for the tweets collected from different countries and US states. In plot A, we can see that most of the tweets are originated from USA, India, and some of them are originated from Great Britain, Pakistan, and Nigeria, and so on. When we zoom into the tweet originated from United States, we see that most of the tweets were originated from California, Texas, and New York, and some of them are originated from some other states, as you can see in the plot B. Next, methods. We reprocess the tweet object we collected using Twitter API. Each tweet contains a tweet ID which is unique to that tweet, and we use it as our primary. There is a created at field which provide posting date and time related information, and we extracted a date and time from that field to use it for further analysis. The original tweet text is provided in a text field which we heavily pre-processed. We clean it by removing hashtags, URLs, and different mentions, and finally tokenize it for further textual analysis. As we mentioned earlier, there is an optional user location field, which contains user location related information provided by the user, and we use this field to extract country, state, and city related information. Twitter also provides the username for each tweet, and the dataset we used contain a sentiment score completed by them, which we use for our sentiment analysis. We tried to cluster countries and US states that showed similar sentiment during the same time. For this purpose, we treated each country and states as 30-dimensional data point where each dimension corresponds to average daily sentiment of the tweets for a particular day of the month. Then we use k-mean clustering algorithm on those data points to cluster them. We use elbow method to determine the number of appropriate clusters. As 30-dimensional data points are impossible to visualize, we reduce them to 2-dimensional data points using principal component analysis for US states and Disney for countries. As we collected huge number of tweets, almost 224.5 million tweets, they contain different type of text. So to summarize them, we did topic modeling. For that purpose, we trained bigram and trigram model on the token we previously derived. Then we trained our LDA topic model on the dataset to find the concurrent trending topic on the dataset. For computational resource limitation, we could train this topic model on only a 1-week dataset from March 19, 2020 to March 25, 2020. So here is our full pipeline. We collected tweet IDs from the LAMSL dataset, then hydrated the tweet IDs and collected full tweet object using Twitter API. Then from the user location field, we collected country and state related information and then clustered based on them separately. Then use dimensional reduction algorithm to visualize them and then do cluster-wide sentiment. And on the right side, we used the tweet text to remove punctuation, URL, and stop words from them, then tokenize them, lemmatize them, then train bigram and trigram model on them, and finally did LDA topic modeling. And then on those topics, we try to derive sentiment based on different cluster. Now, the most interesting part of our paper, result and discussion. Here we can see the cluster plot that we dimensionally reduced from 30 dimension to 2 dimension. Here is the reduced dimension graph of GeoCluster for countries. We have 3 clusters, cluster A, cluster B, and cluster C. In cluster A, we have only UAE and Indonesia that you can see in the bottom right of our plot. Then in cluster we have Ghana, Kenya, Nigeria, and so on, which you can see in the top left of our graph. And in the middle of the graph is cluster C, which consists of Australia, Brazil, Canada, Germany, and so on. Similarly, we reduce 30-dimensional US states data point to 2-dimensional using PCA, and here is the plot. There is also 3 cluster A, B, C. In cluster A, we have California, Pennsylvania, Ohio, Michigan, so on. And in cluster B, we have Texas, Florida, Illinois, Georgia, and so on. In cluster C, we have New York, Washington, and Massachusetts, and so on. Now, the result from topical modeling. We found 3 topics in our dataset, and we'll describe them one by one. The first one is government action. The phrases related to this theme we found in the tweets are plotted in the word cloud in left. We can see word like government, democratic filibuster, dramatic, irresponsible act, president, and so on. And in the right side, we can see the cluster-wise sentiment for different cluster for this corresponding topic, that is governmental action. So we can see that the cluster consisting New York, Washington, Massachusetts, and so on showed highly positive sentiment, while the other 2 remain on the slightly negative side. This could be due to the fact that on March 22, Trump activated the National Guard in California and New York and Washington state. While on March 21, the number of coronavirus cases in Texas was 300 and 5 was dead. And the cluster containing Texas and Florida remains slightly negative relative to the other 2. In theme 2, we have medical issues, tweets related to different medical issues, and those tweets contain phrases like medical, quarantine, tested positive, symptom, test patient and so hospital and so on. And we can see the corresponding sentimental plot in the right side. We can see that again the cluster containing New York, Washington, Massachusetts remain highly positive, while the other two remain highly negative. And we can see a subtle distinction between them on March 21, where the red and blue cluster remain highly positive, highly negative, but the green cluster remain highly positive. In theme 3, we have home quarantine. Here you can see phrases like come, stay safe, hospitalize, work, business, etc. We can again see that the cluster containing New York, Washington remain highly positive relative to the other two, but they all showed a negative trend on March 21, when the number of coronavirus cases in Texas was topped 300 and 5 was dead. But they all showed positive trend on March 22, when Trump activated National Guard in California, New York, and Washington on March 22. This is the sentiment plot for different US states over the full timeline, that is March 19 to April 17. And no theme, topical theme was considered here. It is the total average sentiment over the timeline for different clusters. We can see some positive and negative trend in our plot. For example, when Trump signed 2 trillion aid package for COVID-19, almost all states showed positive sentiment. And when the United States started to lead in coronavirus cases, almost all clusters showed negative sentiment. We can see that the cluster containing New York, Washington, Massachusetts almost always remain on the top of the other two clusters. Maybe because of their effective action against coronavirus. For example, Trump activated National Guard in California, New York, and Washington in earlier on March 22. Now, if you try to plot the average sentiment plot of different countries over the timeline for March 19 to April 17, we see that almost all countries show positive sentiment when Oxford started trial of coronavirus vaccine. When Saudi Arabia and UAE escalated measure to contain coronavirus, the cluster containing UAE and Indonesia showed highly positive sentiment, but the other two didn't. Again, when some African nationals were mistreated and evicted in China over coronavirus, the cluster consisting mostly of African countries like Ghana, Kenya, Nigeria showed highly negative sentiment, while the other two didn't show any effect. So we can say that our pipeline can catch the public emotion using Twitter. So to verify our claim on different independent data set, we collected another data set from October 16 to November 15 over a 1 month period, and try to use the same pipeline to analyze those tweets and see if our pipeline can catch the public emotion. Without any sophisticated analysis, we simply plotted the average sentiment for the top 5 US states. Again, we can see that there is a high peak when Pfizer and BioNTech said that their vaccine is 90% effective. So we can say that our model can capture public emotion from Twitter or other social medias. Thank you everyone for listening to our presentation.